Imagine this. In just a few seconds, life as we know it could be completely wiped out. No sound, no warning. This silent killer travels at the speed of light, and if it were pointed our way, we wouldn't see it coming until it was too late. Hello, everyone, and welcome back to the channel. I'm glad you're here. Today, we're diving deep into one of the most terrifying and awe-inspiring phenomena in all of space, gamma-ray bursts. We'll explore what they are, the sheer power they unleash, and answer the big, chilling question, what would actually happen if Earth was in the direct line of fire? This isn't just science fiction. It's a real, albeit remote, possibility that scientists have seriously considered. So buckle up as we journey to the edge of cosmic destruction. First things first, what exactly is a gamma-ray burst, or GRB for short? Put simply, a GRB is the most powerful type of explosion we have ever observed in the universe. It's an intense, focused beam of high-energy radiation gamma rays, which are the most energetic form of light. These bursts are fleeting, often lasting from a few milliseconds to several minutes, but in that short time, they release an unbelievable amount of energy. To put it in perspective, a single typical gamma-ray burst can unleash more energy in a few seconds than our sun will produce over its entire 10 billion-year lifespan. Let that sink in for a moment. All the energy our star will ever create, concentrated into a narrow beam and released in the blink of an eye. So where do these cosmic behemoths come from? There are two primary culprits. The first is a hypernova. This occurs when a truly massive star, one that's at least 30 to 40 times more massive than our sun, reaches the end of its life. Instead of just going supernova, it collapses in on itself under its own immense gravity, forming a black hole. As material swirls into the newly formed black hole, powerful jets of energy and particles are blasted out from its poles at nearly the speed of light. If one of these jets happens to be pointed toward Earth, we see it as a long-duration gamma-ray burst. The second cause is even more dramatic: the collision of two neutron stars. Neutron stars are the incredibly dense remnants of smaller supernovas. They are city-sized objects with the mass of a star. When two of them are locked in a binary system, they spiral closer and closer together over millions of years until they finally collide and merge. This cataclysmic event also creates a black hole and shoots out jets of high-energy gamma rays, resulting in a short-duration GRB. This is the kind of event that also produces gravitational waves, like the ones first detected back in 2017, confirming our theories about these cosmic smash-ups. Now for the main event, the question that keeps astrophysicists up at night. What would happen if a gamma-ray burst from a relatively nearby source, say within a few thousand light years, was aimed directly at Earth? The scenario is nothing short of apocalyptic. The first and most immediate effect would be on our atmosphere. As the narrow beam of gamma rays slammed into the upper atmosphere, it would be catastrophic for the ozone layer. The intense radiation would rip apart nitrogen and oxygen molecules, which would then recombine to form nitrogen oxides. These compounds are incredibly efficient at destroying ozone. Within seconds to minutes, a significant portion of our planet's protective ozone shield would be obliterated, perhaps as much as 75% of it globally. Without the ozone layer, the Earth would be completely exposed to the sun's harsh ultraviolet radiation. This is where the chain reaction of destruction really begins. Deadly UVB radiation would pour down onto the planet's surface unfiltered. For humans and animals on the side of the Earth facing the burst, the initial blast of radiation would be devastating, causing severe radiation sickness and death. But the long-term effects of the depleted ozone layer would be global. The entire planet would be bathed in levels of UV radiation hundreds of times higher than normal. Sunburns that would normally take hours would happen in seconds. Skin cancer rates would skyrocket and cataracts would become commonplace. Most land animals would be blinded. But it wouldn't stop there. Life in the oceans, which we often think of as a safe haven, would be hit just as hard. The increased UV radiation would penetrate the upper layers of the oceans, exterminating phytoplankton and zooplankton. These microscopic organisms form the very foundation of the marine food web. Without them, the entire aquatic ecosystem would collapse, from the smallest fish to the great whales. Corals would bleach and die almost instantly. It would be a mass extinction event in the seas on a scale we've never seen. Back on land, the consequences would be equally dire. The intense UV radiation would be lethal to plant life. Photosynthesis would grind to a halt. Crops would fail worldwide, leading to a global famine of unimaginable proportions. The delicate balance of our planet's ecosystems would be shattered. The food chains would collapse from the bottom up. With plants dying off, herbivores would starve, and then the carnivores that prey on them would follow. The green earth would turn brown and barren, and we're still not done. The nitrogen oxides created in the atmosphere by the GRB would eventually fall back to Earth as acid rain. This would acidify soils and waterways, further poisoning the environment and making it even more difficult for any surviving life to recover. The sky would also take on a brownish-red tint due to the nitrogen dioxide, plunging the world into a perpetual, smoggy twilight. You might be thinking, this sounds like something out of a disaster movie. Has this ever happened before? Well, some scientists believe it might have. There's a compelling theory that one of Earth's major mass extinctions, the Ordovician-Silurian extinction event around 450 million years ago, might have been caused by a gamma-ray burst. During this event, about 85% of all marine species were wiped out. The pattern of extinction, particularly affecting surface-dwelling organisms, while deep-sea creatures were less affected, is consistent with what we'd expect from a sudden, intense blast of radiation from space destroying the ozone layer. While there's no smoking gun, the evidence is intriguing and serves as a stark reminder that the universe has had a direct and violent influence on the history of life on our planet. So, should we be panicking? Building underground bunkers and stocking up on canned goods? The good news, and I want to really emphasize this, is that the chances of Earth being hit by a life-altering gamma-ray burst are incredibly, astronomically low. There are several reasons for this. First, these events are extremely rare. A GRB is thought to occur in our galaxy, the Milky Way, only about once every 100,000 to a million years. Second, for a GRB to affect us, it has to be relatively close, within a few thousand light years. The universe is vast, and most GRBs we detect are in distant galaxies billions of light years away. At that distance, they pose no threat whatsoever. They are not explosions that expand in all directions like a bomb. They are focused into narrow jets, like a cosmic laser beam. So, not only would a massive star have to die, or two neutron stars have to collide relatively close to us, but the resulting jet would also have to be aimed with pinpoint accuracy directly at our tiny planet. The odds of all these factors aligning are vanishingly small. Astronomers have surveyed our cosmic neighborhood, and fortunately, there are no known candidate stars close enough to pose a significant threat. WR-104 was once a concern, but further observations suggest its jet will likely miss us. So we can all breathe a collective sigh of relief. It's far more likely we'd be hit by a large asteroid, and we have programs dedicated to tracking those. Nevertheless, the study of gamma-ray bursts is a fascinating and humbling field. It reminds us of the sheer scale and power of the cosmos. We live on a fragile, beautiful blue marble in a universe that is filled with both breathtaking beauty and terrifying violence. Events like GRBs highlight our vulnerability and the preciousness of our existence. The universe is beautiful, but it can also be terrifying. It's a place of cosmic serenity and cataclysmic power, and we are just beginning to understand our place within it. What do you think? It's a scary thought, but also an incredible one. The power of the universe is truly beyond our comprehension. If you enjoy mind-bending space content like this, don't forget to hit that like button and subscribe to the channel so you don't miss our next cosmic journey. And I want to hear from you. Let me know in the comments, what space mystery or cosmic phenomenon should we explore next? Thanks for watching, and I'll see you in the next one.